I kept the machines running when they should have rested. The orders were clear, and the steel kept coming, even when it no longer behaved as steel should. I adjusted what I could and signed what I was told to sign. When the failures appeared far from my floor, there was nothing left to correct. By the middle of 1942, the industrial districts of northern England were operating under conditions shaped entirely by war. Britain had been engaged in total conflict for nearly 3 years. German air raids had eased compared to the height of the Blitz, but the demands placed on factories had not. The country's survival depended on continuous production of aircraft parts, artillery shells, vehicles, and mechanical components that could not be delayed without consequences at the front. One such facility stood on the outskirts of Sheffield, within a network of steelworks, machine shops, and assembly plants that fed both civilian infrastructure and military supply lines. The factory occupied several long brick buildings constructed before the war, originally intended for peacetime output. By 1942, those buildings were filled well beyond their planned capacity. Additional machines had been installed wherever floor space allowed. Walkways had narrowed. Ventilation systems strained to keep pace with heat and metal dust. The factory's primary task was the machining and assembly of steel components used in armored vehicle transmissions and heavy transport trucks. These parts were not finished weapons, but without them, vehicles stalled, convoys broke down, and supply routes slowed. The work was classified as essential. Production schedules were issued weekly by the Ministry of Supply and revised frequently as losses overseas mounted. Raw materials arrived by rail under tight allocation rules. Steel quality varied depending on source and urgency. Scrap metal was increasingly mixed into new batches. Lubricants were rationed. Replacement parts for worn machinery were delayed or improvised. None of this halted production. Output targets remained unchanged. The workforce reflected the strain of prolonged war. Many experienced male machinists had been drafted earlier in the conflict. Their positions were now filled by older men deemed unfit for service, women trained through accelerated programs, and younger workers reassigned from other industries. Training periods were brief. Errors were expected to be corrected on the job. Among the senior floor supervisors was Thomas Elwood, a 46-year-old toolmaker who had worked in heavy industry since his teens. Before the war, Elwood specialized in precision fitting and machine calibration. In 1940, he was reassigned to oversee an entire production line responsible for finishing gear housings. His military exemption classified him as a skilled worker critical to national output. Elwood's days followed a predictable routine. He arrived before the morning shift began, inspected machine logs from the previous night, and walked the length of the line to identify faults. He rarely addressed workers directly unless necessary. His role was to keep machines running and defects within acceptable tolerances. By mid-1942, those tolerances were under pressure. Several lathes dated back to the First World War. Their bearings were worn, and replacement components were unavailable. Maintenance crews adjusted clearances manually, compensating for vibration and uneven cutting. Quality inspectors noted a gradual increase in rejected parts, though rejection thresholds were quietly adjusted to avoid stoppages. Elwood documented these issues in routine reports submitted to plant management. The language was cautious and technical. He noted tool wear rates, lubrication shortages, and the increasing difficulty of maintaining consistency across shifts. The reports were acknowledged, but rarely discussed. Production quotas took precedence. The factory operated around the clock in 3 shifts. Lighting was uneven, with blackout coverings reducing visibility near windows. Heat built up in summer months, particularly near furnaces and grinding stations. Workers rotated tasks when possible, but skill shortages limited flexibility. In late June, A shipment of steel billets arrived with visible surface inconsistencies. The material met minimum specifications on paper, but machinists reported unpredictable tool chatter when cutting. Elwood examined several billets personally. He found variations in hardness that would normally have required rejection or reprocessing. Neither option was practical. The billets were assigned to the line with instructions to adjust feed rates as needed. Tool wear increased immediately. Cutting times lengthened. Operators compensated by increasing pressure, which led to more frequent tool failures. The maintenance crew worked continuously to keep machines operational. Elwood recorded the changes and forwarded an updated assessment. He suggested a temporary reduction in output to recalibrate machines and segregate unsuitable material. The response from management referenced ministry targets and emphasized continuity. No reduction was authorized. By early July, absenteeism rose. Long hours and limited transport options contributed to fatigue. Workers who lived farther from the factory often slept on site between shifts. Breaks were shortened to maintain throughput. Canteen supplies were basic and repetitive. Elwood observed these conditions without comment. His position did not allow for policy decisions, but he adjusted shift assignments where possible to keep experienced operators on the most problematic machines. This created tension among workers, but prevented more serious disruptions. The first clear sign of systemic failure appeared in inspection records. Gear housings that passed initial checks failed under load testing more frequently. Minor cracks appeared near stress points. These defects were not immediately catastrophic, but reduced operational lifespan. Inspection supervisors flagged the trend. Elwood reviewed the data and traced the failures back to a combination of material variability and machine vibration. He prepared a detailed analysis, including projected failure rates if current conditions persisted. The analysis was submitted through official channels. It was returned with a notation requesting clarification on whether alternative production methods could meet existing quotas. No mention was made of reducing output. Elwood modified procedures within his authority. He increased inspection frequency on certain batches and instructed operators to scrap parts that showed early signs of cracking, even if they technically passed measurements. This slowed the line slightly, but reduced downstream failures. Management noticed the reduction in output within days. Elwood was summoned to a brief meeting. He explained his actions in technical terms, emphasizing long-term reliability. The response was measured but firm. Output targets were reiterated. Inspection criteria were standardized across shifts to prevent inconsistency. Following the meeting, Elwood complied with the directive. Inspection frequency returned to previous levels. Scrap rates were reduced. The line resumed its pace. The factory continued to meet its weekly quotas. Reports sent to the ministry showed compliance. On the shop floor, however, the strain was evident. Machines required constant attention. Operators worked with diminishing margins for error. Tool failures were logged and replaced as quickly as possible, often with reconditioned equipment. By the end of July, Elwood noted that one particular lathe, responsible for a critical finishing cut, required adjustment at the start of every shift. Its frame had developed a slight warp, likely due to prolonged heat exposure. Under normal circumstances, the machine would have been shut down. Instead, it remained in service. Adjustments were made manually. The process depended heavily on operator skill and attention. Any lapse risked producing parts that appeared acceptable but contained hidden weaknesses. Elwood assigned his most experienced operator to the machine whenever possible. During night shifts, that was not always feasible. Less experienced workers followed written instructions, but lacked the sensitivity developed through years of work. Elwood documented the situation. He noted that the machine was operating beyond recommended limits, and that continued use increased the risk of producing substandard components. The report joined others in the file. The operational problem was no longer confined to material shortages or machine wear. It had become systemic. The factory's structure, staffing, and equipment were being pushed to sustain a level of output that left little room for correction. By early August, Elwood's routine inspections revealed an increase in minor deviations that would previously have prompted immediate intervention. Now they were noted, adjusted, and allowed to pass. The line did not stop. At the end of one shift, Elwood stood near the far end of the production hall and watched completed housings move toward packing. The process was efficient in appearance. Crates were sealed and labeled for transport. The paperwork showed compliance. He made a final entry in the day's log, noting cumulative strain across multiple systems. The entry was factual and restrained. It ended without recommendation. The factory continued operating through the night. By August 1942, the factory's production rhythm had settled into a fragile equilibrium. Output targets were met on paper, yet each shift relied on adjustments that were never recorded in official summaries. Machines were coaxed rather than maintained. Materials were accepted rather than verified. Workers compensated with experience, improvisation, and extended effort. The Ministry of Supply issued revised schedules, reflecting increased losses of vehicles in North Africa and the Soviet Union. Transmission components from Sheffield were now prioritized for immediate dispatch. Crates left the factory within hours of completion, limiting opportunities for extended testing. Elwood received the revised schedule without comment. He adjusted internal assignments to meet the new deadlines. Overtime was expanded. Maintenance windows were shortened further. The factory manager emphasized coordination and morale during briefings, but avoided discussion of technical risk. Failures became more frequent at predictable points. Cutting tools dulled faster when working with mixed-grade steel. Bearings overheated during extended runs. Operators learned to recognize the sound of imminent tool failure and stopped machines seconds before damage occurred. These pauses were brief and undocumented. The lathe at the end of the line continued to degrade. Its alignment shifted subtly during operation. Elwood recalibrated it twice per day when time allowed. During peak output periods, recalibration was skipped to avoid delays. The machine's output passed visual inspection, but showed increasing variation under magnification. Inspection staff noted these variations. Their authority allowed them to flag parts, not halt production. Rejections were tallied against quotas, and excessive rejections drew scrutiny. The balance between enforcement and compliance became increasingly narrow. Workers discussed these issues quietly. Conversations took place during brief breaks or while machines cooled. There was no organized dissent. Most understood the stakes. The war framed every decision, and interruptions were viewed as personal failures rather than systemic issues. In late August, a shipment of replacement cutting tools failed to arrive. Supply chain disruptions delayed delivery indefinitely. Maintenance crews resorted to regrinding worn tools beyond recommended limits. Cutting accuracy suffered. Operators compensated with slower feed rates, which reduced output per hour. Elwood observed the slowdown and recorded it as a temporary efficiency fluctuation. Management responded by extending shift lengths rather than adjusting quotas. Fatigue increased. Errors followed predictable patterns, occurring late in shifts or during overnight hours. One evening, a newly trained operator misjudged a feed adjustment on the compromised lathe. The error produced a batch of housings with slight internal scoring. The flaw was not visible externally. Inspection sampling did not detect it. The parts were packed and shipped. Elwood learned of the incident only after reviewing tool wear logs. He traced the timing and identified the affected batch. He prepared a notice requesting retrieval or additional testing if possible. The notice was forwarded upward and returned without action. The batch had already entered distribution. This was not an isolated case. Similar incidents occurred across other machines. Each instance involved a small deviation corrected too late to prevent shipment. Individually, the deviations were minor. Collectively, they formed a pattern. Elwood compiled a consolidated report summarizing these events. The document avoided emotive language. It listed dates, machines, materials, and projected failure probabilities. It concluded that continued operation under existing conditions increased the likelihood of field failures. The report was reviewed by plant management and discussed briefly during a scheduled meeting. The response acknowledged the analysis, but emphasized that no alternative suppliers were available, and that halting or slowing production would have immediate operational consequences elsewhere. Official doctrine prioritized quantity over durability under certain wartime conditions. Vehicles with limited lifespan were considered acceptable if they met immediate operational needs. Elwood understood this framework. He also understood its limits. September brought colder temperatures. The factory's heating systems were insufficient for full coverage. Condensation formed on metal surfaces during early shifts. Machines required longer warm-up periods to reach stable operating temperatures. These delays were absorbed into schedules without adjustment. Workers adapted by beginning warm-ups earlier. This extended unpaid preparation time but reduced mid-shift stoppages. Elwood observed the practice and did not intervene. It was unofficial but effective. Inspection failures increased modestly. Management attributed this to seasonal effects and labor turnover. Recruitment continued to fill gaps left by illness, transfer, or exhaustion. Training periods shortened further. The factory manager circulated a memorandum reminding supervisors to maintain discipline and avoid unauthorized procedural changes. The memo cited consistency and accountability. Elwood reviewed his recent adjustments and reduced discretionary interventions. As oversight tightened, the gap between official procedure and practical necessity widened. Operators continued to adjust machines instinctively, but supervisors were less willing to formalize those adjustments. Problems were corrected quietly or deferred. A breakdown occurred in mid-September when one of the older milling machines seized during a night shift. The cause was bearing failure, exacerbated by inadequate lubrication. The machine was offline for 12 hours. Production was rerouted to other lines, increasing strain elsewhere. Elwood supervised the repair personally. Replacement bearings were salvaged from a decommissioned machine. The repair restored function, but reduced overall precision. The machine returned to service, with limitations noted only in Elwood's log. The incident prompted a review by plant management. The conclusion emphasized maintenance diligence and operator vigilance. No structural changes followed. As autumn progressed, Elwood noted cumulative effects. Machines required more frequent adjustment. Operators showed signs of chronic fatigue. Inspection staff struggled to maintain sampling accuracy under pressure. The operational problem had escalated beyond isolated failures. It now involved the interaction of material shortages, aging equipment, accelerated training, and rigid output targets. Each factor amplified the others. Elwood's role remained unchanged. He monitored, adjusted, and reported within constraints. His authority did not extend to halting production or redefining standards. His technical assessments accumulated in files, reviewed but not acted upon. At the end of September, Elwood reviewed shipment records alongside failure projections. The data suggested an increasing proportion of components would underperform in service within weeks of deployment. The implication was clear, though unstated. He closed the ledger and prepared for the next shift. By October 1942, the cumulative strain within the factory had reached a point where routine adjustments no longer restored equilibrium. The system continued to function, but its margin for recovery had narrowed to hours rather than days. Each shift inherited unresolved issues from the one before. The Ministry of Supply issued another directive, this time emphasizing uniformity of output across facilities. Variations in delivery volume were flagged as potential inefficiencies. The directive was interpreted locally as a warning. Management relayed it downward in practical terms. Interruptions, even for technical reasons, would draw attention. Elwood read the notice and placed it in his file without annotation. He understood its implications. The factory was no longer expected merely to produce. It was expected to do so predictably, without deviation that required explanation. The lathe at the end of the line remained the most persistent concern. Its alignment shifted more rapidly now, sometimes within a single shift. Operators compensated by making micro-adjustments that were never written down. The process depended almost entirely on individual judgment. Elwood began spending more time at that station, observing rather than intervening. He noted that experienced operators detected instability by sound and vibration, while newer workers relied on gauges alone. The difference was subtle but consequential. During one afternoon shift, Elwood observed a housing come off the lathe with a barely perceptible distortion near a load-bearing edge. The measurement fell within allowable tolerance. Under previous standards, it would have been flagged for rework. Under current conditions, it passed. Elwood paused the machine briefly and inspected the cutting head. He found uneven wear consistent with misalignment. The correction required partial disassembly and recalibration, a process that would take several hours. He considered his options. He could document the issue and allow production to continue. Or he could halt the machine and perform the recalibration. The latter would reduce output for the day and require explanation. Elwood consulted the shift schedule. The next shipment was due for dispatch that evening. Halting the machine would jeopardize the deadline. Allowing it to run risked further production of marginal components. He ordered a brief stoppage under the pretext of routine inspection. The maintenance crew began adjustments. Within 30 minutes, a supervisor arrived to inquire about the delay. Elwood explained the technical necessity without emphasis. The supervisor relayed the information upward. Within the hour, Elwood was instructed to resume production as soon as minimal functionality was restored. Full recalibration was deferred. The machine was restarted with provisional adjustments. Elwood remained nearby for the rest of the shift, monitoring output closely. Several housings showed minor deviations. He allowed them to pass, noting their batch numbers. That evening, Elwood revised his internal logs. He began marking certain batches for post-production review, a practice not officially sanctioned. These notes were kept separate from formal reports. As October progressed, similar decisions accumulated. Elwood intervened selectively, choosing moments where brief stoppages could be absorbed without drawing attention. Each intervention reduced immediate risk, but increased his personal responsibility. Inspection staff began seeking his informal opinion before flagging borderline parts. This altered the chain of accountability subtly, but significantly. Decisions that had once been distributed were now concentrated. Elwood was aware of the shift. He did not discourage it. He believed technical judgment had become the limiting factor in maintaining acceptable standards. A turning point came during a night shift in mid-October. An operator reported irregular vibration from the lathe shortly after restart. The machine was producing at speed. Elwood was called to the floor. He assessed the machine and determined that continued operation would likely produce a high rate of internal defects. He ordered the machine stopped immediately. This stoppage exceeded his informal discretion. It halted the final stage of the line. Work backed up within minutes. Supervisors arrived and questioned the decision. Elwood explained his assessment in technical terms. He referenced recent logs and inspection data. He recommended immediate recalibration, estimating a 4-hour delay. The supervisors contacted management. The response was delayed. During the interval, Elwood maintained the stoppage. He instructed operators to assist maintenance crews. Management's response arrived shortly before midnight. Elwood was instructed to restart the machine with adjusted parameters and to document the incident for review. Full recalibration was denied. Elwood complied outwardly. The machine was restarted. However, he instructed the operator to run at reduced speed and increased inspection frequency, adjustments that were not reflected in official settings. This reduced output but improved consistency. The delay was distributed across the remainder of the shift rather than concentrated in a single stoppage. Elwood recorded the incident in his private notes. He recognized that he had effectively overridden directives through procedural interpretation. The risk was no longer abstract. In the following days, Elwood repeated this approach cautiously. He used technical language to justify parameter changes that slowed production without formally stopping it. These adjustments remained within his authority but stretched its intent. Management noticed fluctuations in output but attributed them to seasonal factors and equipment age. No direct challenge was issued. Elwood's actions increased his visibility among supervisors and operators alike. He became a reference point for decisions that fell between policy and practice. The personal dimension of risk became clearer when Elwood was asked to present his assessments during a management review. He was questioned about variability and asked whether current processes could sustain increased demand. Elwood responded with measured language. He acknowledged the factory's performance while noting technical constraints. He avoided predictions. He emphasized maintenance limitations. The meeting concluded without resolution. Production targets remained unchanged. After the meeting, Elwood returned to the floor. He observed the line with heightened awareness. Each decision now carried potential consequences beyond the technical. The factory continued to operate without interruption. Crates continued to leave on schedule. On paper, performance was acceptable. Elwood understood that his unofficial adjustments mitigated some risks, but did not resolve underlying issues. The system relied increasingly on judgment rather than structure. At the end of October, Elwood updated his private file. He noted that continued operation depended on selective intervention and operator skill, rather than equipment reliability or material quality. He closed the file and returned it to his locker. By November 1942, the factory's operational strain was no longer subtle. The adjustments that had once been occasional had become routine. Production continued, but it did so through constant correction rather than stability. The line functioned because individuals compensated for weaknesses the system could not formally address. Winter conditions worsened the situation. Cold mornings increased metal brittleness. Machines required longer warm-up periods to reach consistent tolerances. Power fluctuations, caused by regional load balancing, interrupted operations without warning. Each disruption demanded rapid recalibration. Elwood maintained his pattern of selective intervention. He adjusted speeds, reassigned operators, and increased informal oversight during critical runs. These measures reduced immediate defects, but drew increasing attention from supervisors tasked with enforcing uniform procedures. In early November, a quality audit was announced. The ministry required random inspections across several factories to assess compliance with production standards. The notice specified documentation review and floor observation. Management prepared extensively. Logs were updated. Inspection criteria were reiterated. Supervisors were instructed to adhere strictly to authorized procedures during the audit period. Elwood reviewed his private notes and understood the risk. His unofficial adjustments were not reflected in formal records. While technically defensible, They existed outside approved doctrine. During the audit, inspectors observed the line during a daytime shift. Machines operated within documented parameters. Output appeared consistent. Inspection samples showed acceptable variance. The audit concluded without formal findings. Shortly after, management issued a directive emphasizing procedural discipline. Supervisors were reminded that deviations, even well-intentioned ones, undermined accountability. The message was not addressed to Elwood directly, but its intent was clear. Pressure increased. Elwood was advised informally to reduce discretionary adjustments and allow established processes to operate as designed. He acknowledged the guidance without argument. Over the following weeks, Elwood limited his interventions. Machines ran closer to their nominal settings. Output increased slightly. Defect rates rose accordingly, though still within accepted thresholds. The lathe at the end of the line deteriorated further. Its instability became harder to manage without frequent adjustment. Operators reported increased vibration and inconsistent cuts. Elwood documented the reports, but delayed action unless failure was imminent. In late November, a significant issue emerged. Several returned reports from the field indicated premature wear in transmission assemblies traced back to specific batches. The reports were technical and cautious, avoiding attribution. Elwood reviewed shipment records and identified overlap with batches he had previously marked privately. The correlation was not definitive, but concerning. He compiled a formal report summarizing machine condition, material variability, and potential links to field performance. The report was thorough and restrained. It avoided assigning blame and focused on risk assessment. Management reviewed the report and escalated it to regional oversight. The response emphasized that field conditions varied widely and that causation could not be established conclusively. Production was to continue. Elwood was advised to focus on maintaining output and to avoid speculative analysis. His role, he was reminded, was operational rather than evaluative. The exchange marked a shift. Elwood's technical judgment, once tolerated, was now viewed as a potential complication. His interventions were monitored more closely. Supervisors began requiring justification for adjustments that deviated from standard parameters. Informal consultations decreased. Operators were instructed to follow written procedures precisely. This rigidity exposed vulnerabilities. Machines that required nuanced handling produced more borderline components. Operators hesitated to intervene without authorization. Minor issues accumulated. In early December, a tool failure on the compromised lathe caused damage that required extended repair. The machine was offline for nearly a full day. Production targets were missed for the first time in months. Management responded by reallocating output to other lines and extending shifts elsewhere. The incident was attributed to equipment age and unavoidable wear. Elwood supervised the repair. He noted that earlier intervention might have prevented the failure. He recorded this observation privately, but did not include it in formal documentation. The incident reinforced existing tensions. Management emphasized compliance. Elwood emphasized caution within the limits allowed. As December progressed, the factory operated under heightened scrutiny. Output resumed its pace. Adjustments were minimized. Defects increased modestly but remained within acceptable limits. Elwood's role became narrower. He continued to observe, document, and intervene only when failure was unavoidable. The system no longer accommodated preventative judgment. At the end of December, Elwood reviewed the year's records. Production figures met expectations. Equipment condition had declined. Field reports suggested reduced component lifespan. He closed the ledger without comment. By January 1943, the factory entered its fourth winter of continuous wartime production. Snow accumulated along the rail lines that fed raw material into Sheffield, slowing deliveries and forcing tighter scheduling. Inside the plant, the pace did not ease. The machines ran through cold mornings and dim evenings, their operation sustained by habit as much as maintenance. The compromised lathe at the end of the line remained in service, though its performance had degraded beyond earlier projections. Repairs conducted in December had restored basic function, but not precision. Its output now required constant attention to remain within tolerance. Officially, it was listed as operational. Elwood continued his work with reduced discretion. His authority had been narrowed by months of emphasis on procedural uniformity. Interventions were permitted only when failure was imminent and visible. Preventive adjustments were discouraged unless explicitly authorized. Field reports arrived sporadically through formal channels. Some noted increased maintenance demands on vehicles equipped with components from recent production runs. The reports were technical and carefully worded. They did not identify the factory by name. Attribution remained diffuse. Elwood recognized patterns in serial numbers and production dates. The correlation aligned with his earlier assessments. He prepared a final technical memorandum summarizing the cumulative risks associated with continued operation under existing constraints. The document focused on machine condition, material variability, and operator fatigue. The memorandum was acknowledged and filed. No action followed. In February, a regional review consolidated output across multiple facilities. The Sheffield plant was designated as consistently reliable based on delivery records. Its inclusion in the report reflected quantity delivered rather than component longevity. Shortly thereafter, Elwood was reassigned to a different section of the factory. The change was framed as routine rotation. His replacement on the line was a younger supervisor with less experience but strong adherence to procedure. Elwood transferred his logs and provided a brief handover. He emphasized machine idiosyncrasies and recommended cautious operation. The advice was noted but not incorporated into formal guidelines. From his new position, Elwood observed the line indirectly. Output remained steady. Adjustments were fewer. The system operated closer to its documented parameters despite known limitations. By spring, the lathe failed again, this time catastrophically. The frame developed a crack that rendered repair impractical. The machine was removed from service. Production was redistributed permanently to other lines and facilities. The loss reduced local output, but did not halt supply. Replacement capacity had been planned months earlier in anticipation of equipment attrition. The transition occurred without public acknowledgement. Elwood reviewed the incident report after the fact. The stated cause was material fatigue and prolonged use. The assessment was accurate but incomplete. No reference was made to earlier warnings or mitigations. As the war continued, newer facilities came online with improved equipment and better material access. Older plants, like the one in Sheffield, gradually shifted to secondary roles or were decommissioned. Elwood remained at the factory through the end of the war. His work became less visible as systems standardized and resources improved. He did not seek advancement. His reputation was that of a reliable, technically competent supervisor. After 1945, the factory returned to civilian production. Wartime records were archived. Many informal notes were discarded during reorganization. Elwood retained a small personal file containing copies of his private logs. He retired several years later. His name did not appear in official histories of wartime production. The factory was credited with meeting its targets under difficult conditions. The components produced there were dispersed across thousands of vehicles, used, worn, repaired, and replaced. Their performance varied. Some failed early. Others exceeded expectations. The factory line had never stopped, even as materials failed and exhaustion took its toll. Its continuity was achieved through accumulated compromise rather than resilience. Elwood's role was not recorded as decisive. He neither halted production nor altered doctrine. His contribution lay in mitigating risk within narrow constraints, preserving function where possible. The system absorbed his efforts without acknowledgement.